Using a graphing utility, graph f of x equals x cubed minus 4x for negative 4 is less than x is less than 4. Find the x-intercepts of the graph of f. Approximate any local maximum and local minima. Determine where f is increasing and where it's decreasing. And without using a graphing utility, repeat this for y equals f of x plus 1, y equals 3f of x, and y equals f of negative x. So in my graphing calculator, I'm going to zoom out a little bit, and let's pull up the graphing calculator. Okay. In my y equals menu, I'm going to type our function that we're working with, x cubed minus 4x. We've got x to the third power minus 4x. And it says specifically that we want to look at it from negative 4 to 4. So I'm going to adjust the window here from negative 4 to 4. So that's giving me an x-min of 4 and x-max of 4. And I think these y values are wrong, but let's take a look first and then I can make a change. Okay, so I'm going to go back to that window and I'm going to bring it back down to our usual numbers from negative 10 to 10. And here we see our graph f of x equals x cubed minus 4x. So first it says find the x-intercepts of the graph. So just visually looking here, we can see those x-intercepts are at negative 2 and positive 2, but your calculator does have a feature that will be able to get us the exact value. So for this example, the exact values will be negative 2 and positive 2. But if your function is kind of shifted anyway, left or right, maybe it doesn't land exactly on one of these tick marks, you want to be able to figure out what that x-intercept is. Oh, there's also an x-intercept right here at 0 as well. So your calculator has a feature in the calc menu. So let's go second trace to get in that calc menu. And this number 2 here is titled 0. And a 0 of a function is also the x-intercept of the function. So we're going to be able to find our x-intercept by using this right here. So we'll go down to number 2. And down here it says we want to find to the left of the 0. So I'm going to move the cursor over to this 0 here. And I want to make sure that my x is to the left of it, which is smaller than it. I'm going to hit enter. Then it asks for the right bound. I'll move the cursor to the right of that 0 and hit enter. And then it says to guess. And we've got a guess there. And then it tells me the actual 0 or x-intercept. So we have an x-intercept at negative 2. I'm going to write that down over here. So we have an x-intercept at negative 2. And then we are going to move on and do the same thing for the next x-intercept. So I want to go into that calc menu, select number 2, and this time we're going to move to this x-intercept at 0. We're going to hit enter at the left of it, hit enter at the right of it, and then guess. And hit enter, and it gives me our second x-intercept of 0. So let's do it again for our last x-intercept. We are going to go into that calc menu again, select number 2 for 0, and we want to make sure we hit enter to the left of it, to the right of it, and then guess. Your calculator uses an approximation technique, so it needs you to give boundaries on where that intercept is so that it can narrow down where that x-intercept actually is. So we've got an x-intercept of 2. So we found our 3 x-intercepts, and then we want to approximate any local minimum or maximum. So in our picture, we have a local maximum that occurs over here. That's a little peak in the graph, and a local minimum that occurs here. That's a valley in the graph. So in that calc menu, we have another function that we're going to use, and that is the minimum and maximum. So I'll select number 3 to find the minimum. We want to make sure we go to the left of that minimum, hit enter, to the right of that minimum, and hit enter. And once again, your calculator uses an approximation technique, so we need to put those boundaries on it, and the calculator will narrow down where that minimum is. So here we have a minimum, and it occurs at 1.15. The minimum value, the local minimum value is negative 3.08. Let's round that. So local min of negative 3.08 at x equals 1.15. Let's find the local maximum. So for the local maximum, I'll go into that calc menu, select number 4. We need to move over to that maximum value, the local maximum value, which is over here. We'll go to the left of it, hit enter. We'll go to the right of it and hit enter. And guess. And we get that maximum value at negative 1.15 with a y value of 3.08. So we have a local max of 3.08 at x equals negative 1.15. So then it says determine where the function is increasing and where it is decreasing. So I think what I'm going to do is take a little screenshot of this. So we can draw on it. So we found the maximum value right here. That was negative 1.15 and 3.08. And the minimum value about here, that was 1.15 and negative 3.08. So the function is going to be increasing until we get to that local maximum. And it's also increasing from this local minimum on up, and then it's decreasing along this section here. So we're going to say that this function is increasing from from negative infinity up to negative 1.15, and it's also increasing from 1.15 to infinity, and it's decreasing from 1.15 to 1.15. Excuse me, this one's negative here, from negative 1.15 to 1.15. Okay, so just going back here, someone pointed out to me that we are restricted from -4 to 4 on this problem. So we're not going to include our intervals until infinity. So let's change those intervals to be limited from -4 to 4. So we're going to say we're increasing from -4 to -1.15 and 1.15 to infinity. We're going to be decreasing, that one was correct, from a -1.15 to +1.15. And just so we're aware, I've put brackets on here, but there are instances where we would put parentheses depending on if you're looking for open intervals or closed intervals. So here's the closed interval where the function is increasing. Parentheses would give us the open interval, and that just means we're not including the endpoints when we make it open. So then let's look at part E. And in part E, it says we want to repeat this. We want to find the intercepts, the maximum, minimum, and the increasing and decreasing if we have a new function, which is y equals f of x plus 1. So this is where our knowledge of transformations comes into play. So we have on the inside a change to x plus 1. This represents a shift to the left 1 unit. So what that means is that our x-intercepts will be shifted to the left 1 unit. So we would have x-intercepts at -3, -1, and +1. That's shifting our x-intercepts to the left 1. Our local minimum and maximums would also be shifted to the left 1. So we would have a local min of -3.08. So that doesn't change the y part, it only changes the x part. And that would be at x equals 0.15. So I'm taking this x and subtracting 1 from it to move it to the left 1. And we'll have a local local max of +3.08 at x equals -2.15. So that shifts that x to the left 1. So that's also going to shift our increasing and decreasing. So our increasing will shift all the x's to the left 1, so that will go from -5 to -1, that would be -2.15, union with 0.15 to 4. And I just noticed here that I made the same mistake that I did earlier, including infinity here. So that should be a 4 instead of an infinity. So I'm correcting that to be a 4. And when I shift this to the left one, that becomes a 3. So then we want to do this again, but for the function y equals 3 f of x. So multiplying by a 3 onto our f of x is a vertical stretch. So it is not going to affect our x-intercepts because the y-coordinate is a 0. So multiplying by 3 still keeps it 0. So we're going to have the same x-intercepts of -2, 0, and 2. The increasing and decreasing will also stay the same. However, the local min and local max will get multiplied by 3. So we will have a local min, and it's going to be 3 times the amount that we had before. That 3 times is this 3 that we're multiplying by. 3 times, but the x will stay the same. So that will be at 1.15. We'll have a local max of 3 times that y value at x equals -1.15. So what is 3 times that value? So that's 9.24. So as I said, because this transformation affects only the y-coordinate, the increasing and decreasing will not change. It will be -4 to -1.15 union with 1.15 to 4 for the increasing, and decreasing goes from -1.15 to 1.15. So final one is y equals f of -x, and that is g. So we've got y equals f of -x. So the transformation that we're seeing here, multiplying by a negative, will do a horizontal reflection. So since we have the graph up here, what that horizontal reflection will do, it will take the hump that you see on the left, and it's going to be now on the right, and this hump that we see down here, I guess this valley part right here, will be over here. And so our overall picture will look something like this when we do that horizontal reflection. So for our x-intercepts, those will reflect, but in this case, because of some symmetry, it won't change it. So this x-intercept gets reflected over to this side, and this x-intercept gets reflected over to this side, so they end up being the same, of -2, 0, and 2. The local min and max, they will change. I think all my markings on this picture have got me a little bit confused, so let's see if I can clear up. So let me use a highlighter here. So originally we had a local min right here, and because of the horizontal reflection, it moves over here. So our local min will now be -3.08, but instead of it being at positive 1.15, it's at -1.15. And we started off having a local max right here, and the reflection mirrors it over here. So our local max will have the same y value of 3.08, but because of the reflection, it's mirrored it over to a positive 1.15. And then I also see that our increasing and decreasing has changed. We're now going to be decreasing along this section here, and also decreasing along this section here, and increasing in the middle. So we have decreasing from -4 up until where our local minimum is, and then more decreasing starting at the local maximum until 4. And we're going to have increasing in the middle from -1.15 to 1.15. So there was a lot of work to do in that problem. Let me zoom out so we can see it all. Thank you for checking out my videos. Have a great day.